Yeah, my name is Bob Petch from Wilde Analysis. And first of all, I'd just like to say thank you for taking the time today to join me while I talk about some of our experiences that we've had in the safety and reliability team at Wilde Analysis over the recent years when helping people implement tools into their business, particularly within reliability programs. Tools are universal, and I believe they apply to all of our lives in some shape or form. And so the definition that I'm using here when I'm talking about tools is something that helps you perform a particular activity. Now, that's intentionally a very loose definition, and it can refer to anything ranging from physical tools like spanners through to the diagrams that we can use to or jot down on the back of a napkin, right through to some advanced data collection and processing systems. So it's a very, very loose definition that I'm going with. The approach that I'll be talking about today really centers around understanding the needs behind the tool in order to choose something appropriate that can then be implemented effectively. So in order to do that, I'll look at some of the typical motivations that we see within reliability programs, as well as some of the obstacles encountered. And we're coming at this from an industry agnostic standpoint, as there's a lot of commonality across both industries and applications. Then I'll highlight some of the key considerations to factor in when looking at tools. And then at the end, I'll summarize the key lessons that we've learned at Wilde while implementing these tools, and for which we've developed a framework which we use either when discussing requirements as part of a gap analysis, or even implementing tools as part of a larger project or program. And I'd like to share that framework with you in the hope that it will provide you with some utility when either selecting new tools for yourself or developing a business case. Equally as well, I'd just like to mention that this talk is intended for both new and existing reliability programs and is intended to be completely tool agnostic, as there's not any particular tools that I'd like to advocate at this stage. It's very much coming in from almost first principles. Okay, so just to help illustrate the standpoint that I'll be coming from today, I'd just like to explain really the nature of our business at Wilde Analysis, and just to give you a bit of a high-level view of the types of activities that we're involved with. Wilde Analysis Limited, we're a company that was formed in 1980, and we're based in Stockport in South Manchester, and we comprise three key business units. We've got design simulation, manufacturing simulation, and safety and reliability. And it's safety and reliability is the business unit that I sit in. Each business unit really splits the time across three key areas. We've got the consultancy portion of our business, where we'll be performing analyses such as finite element analysis, computational fluid dynamics, and various safety and reliability type things like HAZOPs, failure mode and effects analysis, build and reliability block diagrams. We also provide training courses, both in terms of the methodologies that we carry out ourselves, and also the software packages as well, because we became a value-added reseller for various different software packages starting in 1987. And so we use those alongside our consultancy project, build the training courses around them and so forth. And we believe that it's the combination of these three components in our solutions that gives us quite a unique position in the market, and also quite a unique experience as well when we're talking to people about their problems and how you go about solving them. So yeah, my role at Wilde is to manage the delivery of those solutions in reliability engineering from start to finish. And as a result of that, yeah, I've had a lot of very interesting conversations, which has helped me learn a lot. And I think quite importantly as well, it's often overlooked to those people that are starting out with a reliability program, and there's a lot of obstacles to overcome. And so this talk in particular, I hope will be useful for those, and there's certainly no stupid questions in getting started out. At Wilde Analysis, we don't focus on one single industry, but rather we specialize in applying specific technologies where they will be useful. So on this slide, I've just got a few key industries that we typically work with. It's a very broad spectrum, as you can see, and there's many differences between industries, things ranging from the duration of their projects, what budgets are involved, and what their motivations are. But there's also a lot of similarities. The core tools that will be implemented for a reliability engineering program don't vary too greatly. There's, of course, differences in the nuances, but the tools themselves and the approaches taken are quite common, and I think it's useful to share that. Okay, so yeah, if I just recap the definition that I go with for a tool is something that helps you to perform a particular activity. Understanding what the aims and objectives of an activity really form the foundation of the approach that I'm about to outline here. And so I thought it'd be useful just to run through some of the typical categories really that we tend to put the motivations for a reliability program into. So the key thing here really is that these motivations all center around risk. It's very much a risk management approach that leads people down this avenue. And these are quite often driven by the nature of the industry that somebody will be working in. Now, typically we are not just looking for one of these. It's often many, and also some sort of combination as well of, and the interactions and the trade-offs that go in between these things. In some cases as well, there'll be regulations in place that don't just guide but also enforce particular requirements and needs that have to be met. And in others as well, it's not quite so clear-cut. There may be some guidance, or in some cases, it can just be driven by market forces. One thing as well that certainly we're seeing a big change in is reliability requirements being reflected in contracts. So OEMs inheriting the reliability from their suppliers, they need to manage that throughout the supply chain. And so it's certainly a change that we've seen over recent years, that there's a lot more pressure being put on to ensure that these risks are being managed. So I think quite important early on just to discuss how it is that we actually go about achieving reliable designs. And the way that we see it is it's a hierarchy of objectives. So just working from the top to the bottom, what we want to do in the ultimate case is prevent failure from being possible in the first place. So if we were looking at a fire, the best fireman would be someone who basically was able to uninvent fire, somehow remove an element of the fire triangle. So oxygen, heat, and fuel, ignition and fuel. Alternatively, if we can't do that, then maybe we can correct the causes. So again, looking at the fire, maybe we could look to limit initiating events and remove, say, a source of ignition. If we can't do that, then maybe we can just learn to cope with failure. So applying some sort of plaster or Band-Aid to the wound. Something to stop the bleeding. So in the case of a fire, that would be having a sprinkler system that could at least put out a fire should one initiate. And at the very least, what we'd like to do is predict how likely failure is to occur, and ideally when failure is likely to occur. So even if we can't stop the fire or put it out, we can at least make sure that people are a safe distance from it when it is there. Now, there is, of course, a fifth option, which is to do nothing. But hopefully, given the fact that you've all joined the call today, then that's not a position that you're in. One of the things I like to do with this really is to just identify where people sit on this hierarchy. How close to preventing failure are we? Because in an ideal world, we would just jump straight to the top, but usually we need to start at the bottom, and through the lessons that are learned along the way will lead us to that utopia of ultimately preventing failure. Now, when choosing tools, there's always going to be trade-offs. I'm yet to meet anyone at all who doesn't have any accuracy requirements or they've got an unlimited budget. And so really what we're looking for is the balancing point, which is just to identify how good is good enough. And equally, do the resources that are available reflect this? Quite early on, I think it's important to identify if there's any showstoppers or if there's any expectations that are too high. All too common, you see somebody that has only got a couple of weeks to perform some work, which really needs a year of developmental effort to complete. Okay, so this brings me on then to the first of 7 lessons that I have here, and that is that we need a common understanding of objectives. So these should be agreed as part of the team and thoroughly documented as well. It can be very easy, I think, to assume that we have a common understanding of what the objectives are, but actually there's some misinterpretation between those, and that problem becomes greater the larger the team and the number of stakeholders involved. So having well-defined, agreed and documented objectives really is the foundation of everything that follows on from this, such as when we get to performance measures, screening processes, and also assessments of effectiveness. Another reason why it's important to document all of this is because objectives can change very, very quickly and quite substantially as well. So keeping a record of how a program has matured will help identify as well if there's any inherent issues with it as well. Okay, so in 2020, we can't really talk about a reliability engineering program without mentioning data. Its role is becoming central, really, just really owing to its availability and how much easier it is to utilize now with a lot of the new tools that we do have. So this diagram really just outlines the general process in terms of what we're trying to do with the data, which is collected at the bottom, through some form of cleaning and classification process, filter out a lot of the noise, which we can then summarize using methods like summary statistics or data visualization. And then that can also be translated into models, and those models can be used to make predictions. Now, the process itself will allow us to make decisions along the way. So quite early on, information can be gleaned from the data that can inform decisions. But the premise being really is that the more we distill the data into the information, the greater our confidence should be as well in the conclusions that we can draw from it. One of the things I think that's very important is that while we're working with the data, there's a need to periodically as well review the categories that we are using and the tools and the methods that we are using as well, just as things evolve. And to continually as well review that against our objectives to make sure that A, we are meeting our objectives, and also to double check that the objectives that were initially defined continue to be appropriate. So one of the biggest questions that we get asked, particularly in the early stages, is what target should I be going for? What reliability should I be looking to set? What's necessary? And there's no really any straight answer for that of how reliable is reliable enough. And there's a number of different ways that we can look at it, be that counting the number of failures, trying to measure customer satisfaction, or just looking at the costs involved with things. I think rather than just trying to set an arbitrary target, it's best to initially measure where we are now, where do we stand, what's our current performance at, and then based on that, reason and see where we think that we could get to, and then use that as the basis for developing a target. So early on, if we can take the available data and use it just to draw a line in the sand, it will give us or begin to paint that picture as to how we're performing today. But we'll also as well highlight deficiencies in any data collection or recollection systems. For example, if we're unable to count how many failures there have been in the last year, then this is a very good starting point for outlining what sort of tools we may require to actually drive reliability improvements. Equally, there's metrics such as the MTBF, which, although not perfect, provide a really useful metric that allows us to perform comparative studies and see if we're getting better or worse and improving things. Okay, so the second lesson really that we try and act on is to measure performance from the beginning in order to track progress. What we want to do is just start with whatever it is that we've got available. It doesn't need to be perfect. As long as it's useful, and we can find some utility with it. This also as well can identify whether there is an issue at all, and just to really help focus efforts early on. Typically as well, we tend to see that there is lots of data already available, and that we just need to start to analyze it. And again, we can then start to see where the value lies in the data that we do have around us. Okay, so yeah, in the age of big data, so we tend to find that companies are surprisingly quite rich with data, but it's more the availability and the access to the data which bears the problems. And the main reason for that really is what I would call data fragmentation. Information or data will come in through help desks, engineering records, maybe some maintenance systems, spare parts, inventory levels, audit reports, field reports. There's a lot of data out there, a lot of record keeping going on in most places. The difficulty is that it's very fragmented. It's stored here, there, everywhere. People aren't quite sure where to get access to this sort of thing. So that can make the analysis quite slow, the analysis process of the data. And in some cases as well, it can be completely impossible, either due to security controls, so permission, not giving people access to particular databases or systems, or it may just be a hard access if it's stored on a network drive somewhere that's on a different network and there's no access to the building. So it can cause a real problem. Now, there are some companies that we do come across which are working hard to address this. So things like data warehousing is a very useful approach to try and bring all the data together. And equally as well, we do see some companies that have made no progress with this, and that can be an immediate stumbling block for implementing a lot of tools, because if we don't have access or ready access to the data, it's very, very difficult to run these analyses. So that then comes on to the third lesson, which is to try and ensure that data is centralized and readily accessible. Otherwise, it can be of little or no use. Now, this is easier said than done, of course. In our experience, there's quite a lot of translation that's needed. Even simple things like date formats can vary significantly from one system to the next. And so, yeah, this is quite, or can be quite a large project in itself to achieve. But at the very least, what we advocate is that even if you can't bring all of the data into one centralized place, at least letting people know what information is available where across the business can break down some significant barriers. Okay, so moving on to the actual tools themselves then. When we are looking at tools, I think it's important to consider what is the purpose of the tools that we're looking at. Because we'll need them for many different things. Now, the first one really is, in this context of reliability engineering, is to understand risk. So we'll be looking to identify risks, assess them, and also quantify those risks as well. So we'll be looking at assessing design options off the back of that. So critically looking at a system and trying to identify if there's any weak spots. Is it fundamentally capable, or will the system just not last? And also quantify how likely a failure is to be, because then we can make predictions about how many spare parts we'll need, what kind of a warranty burden will be faced, and so on. Now, reliability engineering on the whole tends to be weak on absolutes, but it's very strong at making powerful comparisons. And so we can, if we've got tools that allow us to make those comparisons, and we can make decisions between option A and option B. Equally as well, once we do start to get some real world data coming back in, then we need tools that can check the performance. So is the current system, is that meeting expectations or predictions? So things like MTBF values can be useful here, just to compare against the original specifications, and then translate that into probabilities of surviving another year, another 2 years. Equally as well, the tools themselves have the additional benefit of documenting the decisions. So it may be the primary purpose of the tool or an additional benefit of the tool, but these decisions are vital information that we want to keep inside the business, and not just someone's head. So if we can get that down on paper, all the better. Now, a tool may fulfill one or multiple purposes here. And again, I'd just like to reinforce the point that it's essential to have a feedback loop with this, which is how do we translate these findings into real world decisions, and then how does that affect the risk that's ultimately faced. Okay, so fourth lesson here is to keep an open mind while looking for available tools. And if a tool is specified at some point in the process, it's worth just asking why to confirm that that is the best tool for the job. All the tools have got their own strengths and weaknesses. Now, it's important, I think, to filter them out, but equally we don't throw the baby out with the bathwater. As well, early on in the process, I think it's important to cast a wide net. Because at this stage, we're just trying to identify options. We're not looking to make any commitments at this stage. Okay, so once we've got a list of candidate tools, it's worth then considering what makes a tool valuable, or in particular more valuable than another. So with this selection process, start to factor in things such as the utility of a tool. Will that tool do what we need it to do? For example, if we are looking to forecast warranty performance, choosing between root cause analysis or Wilde analysis can become a bit more clear-cut based on the quantitative nature of one versus the qualitative nature of the other. Equally as well, it's worth looking beyond the immediate need and asking what insight we can gain. So what extra information will surface as a part of the of using the tool. So typically these result in aha moments, or spotting just the odd thing here and there that really jumps out, such as when you realize that the reason that the machine keeps stopping is because of a very cheap 80 pence switch that just keeps failing, and spending just a few pounds more will have a huge impact on the reliability of the system. Equally as well, we want to look at how robust the tools are. We need tools that we can depend on and trust. And if there are any concerns, then that can massively devalue a tool. If we don't trust the results, or we don't trust the repeatability of it, then we've got a problem there. Also, as well, it's worth looking at the reusability of the tool. In some cases as well, a tool may be more complex to get set up, but once it's in place, it then becomes very reusable and very repeatable in other areas of the business as well. And so That's an important consideration when assessing a tool on its merits. Now, the flip side, of course, to tools is just looking at the costs involved. Now, there's a number of different costs that go along with it. So one of the most apparent ones, particularly in the early stages of getting tools, is any hardware that's involved. So if we're looking at physical testing, there could be a need for environmental test chambers or shaker tables. If it's condition-based maintenance, looking at sensors and some outlay there. Or if it's more workshop-based activities that are being performed, then meeting rooms, whiteboards, computers, that sort of thing, and getting hold of those. Equally as well, much like with the advent of more data, there's an increasing demand on software as well. Now, the capability and the availability of the software is improving, but the cost is not always inconsequential. So in addition to purchasing software, there's also factors such as ongoing maintenance and keeping on top of it, as well as maybe some back-end cleanup and administration of it as well. But perhaps the hardest thing to quantify is the costs associated with training people up on the use of these tools, because that varies a lot depending on the individual. There's going to be some people who are happy just getting a book and working through the theory, others that are best off going through some sort of mentoring program. And then equally as well, we need to factor in the ongoing cost of maintaining those skills as well. Okay, so one of the methods that we use just to develop the shortlist of the tools is something like a radar plot. Now, these are especially useful for business cases, and what we're looking at here really is just objectively measuring or assessing the pros and the cons relative between tools. So in this case, I've got an optimistic scale between FMEA and FRACAS. Now, your mileage will, of course, vary depending on the nature of the business or the industry that you're in. But tools like this are useful to share as well, because if there is disagreement, it's very easy to highlight where those differences are. So if you think that actually one is more labor intensive than the other, you can highlight that and change it as needed. And then here is just an extract that we typically use when going through the tools, is to then just summarize various tools and to say which ones we suggest putting into place based on how capable it is at addressing our problems, how valuable that will be, what priority we think we need to do in terms of getting it started, and also what time frames are involved as well to begin delivering results. So that's that. Then there's the fifth lesson really, which is to then choose the tools that you're going to do and to prioritize those based on the reliability program objectives, and hence why the first step is so important. The general rule of thumb that we go with is to choose the simplest tool that will allow you to complete the task, while not forgetting about the fringe benefits such as additional insight that will come along with it. Okay, so it's also, I think, important while going through this just to discuss what can go wrong. So really what we want to avoid with any of this is to prevent any loss of momentum that ultimately leads to disengaged stakeholders. So there's a lot of key themes that we tend to see both in large programs and our own projects as well. So that really starts with unclear motivations. And as I said before, this is the kind of thing that gets more difficult with the more people that there are involved. And it's very common and easy, I think, to underestimate what is required. So things like time, people, budget, what resources are required to actually put these things into practice and to maintain them moving forward. An urgency, a lack of urgency, and I'm not feeling the need for this, as well as general complacency around the tools, which equally as well can go too far the other way, which is taking on too much too soon and overloading people. Finally, though, really, I think that where people really start to lose interest in this is if there's a lack of results, which is why it's so important to measure performance early on so that you can actually start to track results, as subtle or as small as they may be. Because otherwise, that can just lead to frustration and just fuels any skeptics' prior beliefs. So, sixth lesson, just to highlight there, is that it's essential to prioritize our efforts and then communicate those successes back as well. So, by measuring and reviewing our performance, we can account for that in an objective way and feed it back in a very concise way as well. Okay, now just one final point really for me when it comes to talking about tools, and that is about the importance of process. Tools are just part of a bigger picture, and we need robust processes really to ensure that tools are used correctly and at the right time. For example, we all have our own way of working, our own process when it comes to Outlook. Do we check our emails hourly? Is it the kind of thing we leave just before lunch and at the end of the day, or do you respond to them as soon as you get a notification? Everybody's got a process there, and it's essential to getting the most out of the tools that we do have. So to that end, we think that there's things like regular meetings and periodic reviews just to verify the objectives are being met and to also validate the results that we're seeing. These things really are best handled when there's a steering committee involved that can be involved right from the start and can be involved along the way, and to actually make sure that once there is a handover complete, everything goes to plan, as it were, and to continue supporting that integration. Okay, so yeah, our seventh and final lesson then is to make sure that there's robust processes in place to support the implementation itself. And this is one of the biggest reasons why we often see tools failing. In the long term is that the process required to use those tools correctly is not considered, at least until too late, and if not at all. The two need to go hand in hand. Okay, so just to summarize then, the 7 lessons we've gone for, or just gone through here, is that first and foremost, we need to understand what the objectives of the reliability program are. We need to measure performance early on, or as early as possible, to track progress, and also as well to identify any weaknesses in our current data that we've got. Any data that we do have should be stored in a centralized location that is easily accessible, or at least educate people on where information or what information is available where. When we are considering tools, try and keep an open mind as possible and cast the net far and wide. When selecting the tools, contrast every single one from the candidate list back to the objectives that were outlined at the start of the program. And then use that to prioritize the efforts and communicate any successes that have come back, which really highlights the importance of the second lesson, which is to measure the progress early on so that we can quantify what gains have been made. And then finally as well, just really at all points along the way, ensure that there are robust processes in place to support the implementation at every step. Okay, so just finally, this is just one last visual aid, and this is the framework that we use as part of our tool selection process, which then rolls forward as well into the implementation side of things. So we simply work from left to right, and it just really summarizes those seven lessons learned into a number of pragmatic steps that can be done. Now, the most important thing really is that you make sure that you've completed the step on the left before moving to the right-hand side. If we haven't built those foundational blocks, then it becomes increasingly difficult to perform the subsequent tasks.